Hello everyone, welcome back to the channel. Today we are tackling something super practical. I'm going to talk about network cabling and media types. So I'm just going to break down on copper, fiber, and wireless. These are the three main ways our devices actually connect to each other. On top of that, I'm going to cover the different Ethernet cable types, like a straight through, crossover, and console cable. Although some of them might not be necessary these days, but understanding them is going to help you a lot. I'm also talking about real world stuff like power over Ethernet, PoE, something that used to call it PoE actually. And also I'm just going to talk about some limits about the distance that you can send signals on different media types such as cables and also fiber. And when you really need to step up to things like single mode fiber or 40 gigabit per second, 100 gigabit per second, or even more than that, these kind of links. And also in the end of the session, you're going to understand the theory of this. You won't just know the theory, you will know about when to pick, for example, copper over fiber, or when to pick fiber over wireless or something like that, and then which one of them is going to be more practical for your case. In networking, we say nothing is better or worse. Everything is it depends on your needs, and based on the decisions that we make, you can just try this or that. Okay, so why media matters? Why should we really go for media? As a matter of fact, networking is very much like people around the city. When you talk about copper, this is like your regular roads. It is cheap everywhere, great for local travel. You can use it for everything. When you talk about fiber, this is like a bullet train actually. It is very fast, super fast actually, and perfect for long distances. But what about wireless? It is like flying. There is no road actually. You don't need any road, but and this gives you a lot of flexibility. But sometimes it is very bumpy because of the interference that you might have, because what you call a turbulence in aviation actually. So every option has its role, and it is good for networking. Usually, use a mix of all of these three: copper, fiber, and also wireless. So what about copper cabling? Let's just take a look at these types of cables that you have on the right actually. I'm not going to write anything on the pictures because you can easily see everything. And when you say copper actually, what you usually mean is twisted pairs of Ethernet cable. You can see that there are a series of cables and they are twisted to each other. Look at this right cable. You can see that these are twisted to each other, two by two, as a matter of fact. And this is called a UTP. You can see that there is no shielding around this. If there is a shielding like this left one, for example, then this is going to be called STP. UTP, by the way, stands for unshielded twisted pair. You can see that they are two by two, so that's a pair actually. It is very cheap. It is everywhere. You can just think of offices and home everywhere that you can use this kind of thing. For SCP, when you have a lot of let's say magnetic noise, most likely you would say magnetic noise. For example, behind the fridge, near some generators, where you need to have some kind of I don't know, everything that has kind of a magnetic field. Around that, you need to use something which is shielded with this extra layers to just make sure that your signals are not going to be lost, or they're not going to be destroyed. Something which is called attenuation is extra, let's say, signals that are induced into these kind of cables actually. So there are different categories for these kind of cables, and understanding that is going to help you a lot. Cat 5 is very old, so we go with Cat 5e, and Cat 5e supports up to 1 gigabit per second, and the maximum length that you can use Cat 5e is going to be 100 meters. So if you have two switches, for example, 100 meters away from each other, you can use a Cat 5e to connect these two to each other. Cat 6 actually has shorter range. You cannot really go beyond 55 meter, but you can go faster. so it supports up to 10 gigabit per second, and it is a little bit more stable than Cat 5e. But like I said, the range is going to be very limited. Now the range is going to get back to 100 meter in Cat 6a. So if you just go with Cat 6a, so also you're going to have 10 gigabit per second, but you can go something like 100 meters in the length of the cable. When I say length of the cable, that's going to be the maximum length of the cable. Sometimes you don't really need these kind of length, but again, this is going to be for one connection, so you can have increased connection by adding some devices in between, like repeaters or something like that, switches or something like that. Then we have Cat 7 and Cat A. So if you want to go for 25 gigabit per second or 40 gigabit per second or even more than that, then this is the one that you need to use. In data centers, actually, these are going to be used a lot. And you don't really need longer cables in data centers because servers are very close to switches, for example. They are in just the same rack, and you just go something like 2 meters, 1 meter, something like that, this kind of cable. Also, most likely you're going to connect it to a patch panel in front of the rack, on top of the rack actually. So these are very high speed and you can use them. So like I said, copper cable actually is like a road, and the upgrades can go from Cat 5e, like I said, which is kind of a two-lane road, something like that. I'm just giving you an analogy. And Cat 6a is going to be something like multi-lane highway. Cat 8 is like expressway. It is for race cars, so you just go with that kind of a cable. So why do you use copper? Most legacy devices, of course, need to connect using coppers. So PCs, printers, VoIP phones, these kind of original devices, normally copper is going to be okay for them. For office LANs, actually, you're going to use the switch devices. This is going to be copper most likely. If you want to power some of the devices using your switches, kind of distribution of power using your switches, which is called power over Ethernet or PoE actually, then you're going to use copper. So for example, IP phones or some wireless access points, for example, receive power from the switch that they are connected to. There's a tip. Ethernet is rated for 100 meters, like I said. If you want to use power over Ethernet, you cannot really go beyond 80 meters. So 100 meters maximum for Ethernet, but PoE is going to limit that to 80 meters just to make sure that it is reliable and power is going to be okay. So sometimes, for example, you want to get power to your access point. It cannot really be very far from your switch in here. What about the cable types? So there are different cable types, not based on the cable itself, but based on the connectors actually, and the way that you connect the wires. So inside the cable, as a matter of fact, inside an STP or UTP, you have something like 8 or more wires actually, and like I said, they are twisted to each other in pairs. So but based on the color of the wire, you can just understand which line is this and which line is that. So you can just connect them to the correct pin inside the connector. So based on this kind of connection, if both sides are the same, for example, that is going to be a straight through cable. So say, for example, on this picture here, you can see that each one of these lines, for example, the striped green, the striped orange, and then blue, and the striped blue, and then orange, and then striped brown, and then brown. We can see that both of these are in the same order. So if the order on both sides for the wires are the same, so this is called a straight through cable. So when you connect different device types, for example, you are connecting a PC to a switch, you are connecting a router to a switch, you are going to use this kind of a cable. There is another type of cable which is called crossover, and we are going to talk about this later, but you should say, for example, cables are going to change their order. You can see that there is a number in front of each one of these wires. So if you have this order on one side, and on the other side you change 1 to 3. So 1 and 3 are going to be replaced, and also 2 and 6 are going to be replaced. So you would say 1 to 3, 2 to 6. That is what you can remember for crossover cable. If you just move these on the other side of the cable, then you're going to have something which is called the crossover cable. Why is this? Because some of these wires are used for sending and some of them are used for receiving. Now, by changing this, you are changing the senders and receivers place on the other side. So this is called the crossover cable. And when you connect two similar devices like PC to PC, switch to switch, then you're going to use this kind of a cable in here. Now, some of the legacy devices actually didn't need you to go for crossover cable. They would understand that they are connected to a similar device and they would change the order of their pins themselves. You wouldn't need to use different type of cable for that. But nowadays, actually, again, this is not available for us. That kind of a feature is called Auto MDX. And some of the devices support that, some of them do not. But actually, like I said, if you want to use devices similar to each other, then you need to go with crossover cable. There is another type of cable that you can see this at the bottom, and this is called a console cable. And it used to be called a rollover cable, if I remember correctly. Because these kind of cables are nowadays are not so much in use. In that kind of a cable, we can see that on one side we have a specific type of connector, which is an old type of a connector, which is called a serial connector. Most likely, you're going to use this to connect your printer. And on the other side, you can see that this is going to be very different. In this picture, you can see an RJ45 connector. But sometimes you can see that nowadays we use something like a USB connector on the other side. So most likely that's going to be a USB connector. And if you don't have that, you can just use some adapters to, connect this to the USB port on your device and also the device which you are trying to manage that. So this is used for management most likely. Okay, so let's just take a look at the pros and cons of copper, and after that move to another type of media. So what are the pros? What are the advantages of copper? It is cheap, actually. You can just buy a lot of this with a limited amount of money, so you don't really have to pay a fortune on copper. And the other thing is easy to install. Actually, using fiber is a little bit clumsy. If you just bend it too much, then it's going to break. But for copper, this is not the same. And also, on copper, you can have power over Ethernet. What are the cons? What are the disadvantages? You have limited distance. You cannot really go beyond 100, and if you want to have PoE, 80 meters. And also, it is very susceptible to interference. What I mean is, if you just go over a magnetic field, near a magnetic field, then you're going to have something which we call it attenuation. That's going to introduce extra signals into the copper, and then you're going to have your data lost, or the quality is going to drop a lot. And also, this is not very ideal because of the speed that gives you. It is not very good for backbone networking. What about fiber optic? That's going to be the newer ones. And also, it is sending light signals actually instead of electricity, which means that we don't have any kind of attenuation in magnetic fields. And electromagnetic interference is going to be kind of eliminated in here. Now, the kind of optic cables that we have, first of all, you should know that we have two strands of cable. One of them is going to be used for sending, and one of them is going to be used for receiving. Also, like I said, because this is, created with glass strands, so it is susceptible to, break when you bend it too much. So you should be very careful. And there are some rules, for example, for bending this kind of a cable. For not breaking it, and also not breaking the light signal actually, because the light signal cannot really be bent so much in this kind of a cable. But there are two modes for that. One of them is called single mode. A single mode is used for long distances. On a single mode, actually, what you have is the core is very small. Laser is used for creating the light beams, and also, yeah, like you can solve this out. Okay. So, like I said, laser is used for creating the light beams. You can send this kind of a light signal super far, let's say tens of kilometers. And it is very perfect for building to building connections or campus connections actually. So you have a switch here, another switch, something like 5 kilometer away from me, 3 miles away from me. So this is going to be the good choice to connect these two switches to each other. The other type is called multi-mode. So single mode is called SMF actually, single mode fiber. Multi-mode is called MMF or multi-mode fiber actually. Now multi-mode has bigger core. And when I say core, I mean the glass core that is inside the cable actually. And it uses LEDs to create the light beam, which is cheaper than laser actually. And this means that you cannot really have a very high quality lighting here, which means that you cannot really go too far. So for short runs, this is going to be nice. And also inside data centers, for example, racks or campus floor, which are shorter distances, you can use this kind of a cable. Single mode is very much the king in here if you want to send data across the town, let's say. Multi-mode is going to be like a flashlight, right? It is bright, but it fades very fast. What about the connectors? You can see the connectors, some of them, for example, in here. And now the connectors are, in different form factors. And also you can see them called like LC, SC, ST, and these are just the plug and attach the fiber. So you can just put the fiber inside them and that's it. Uh, for devices, actually, we have something which is called transceiver. Transceiver is something that this is a word, combined of two different words. For transmitter and receiver. Actually, I was trying to figure out the first part, transmitter, and so you can have these kind of devices, and they have different forms, and some of them is called SFP and SFP plus. These are a little bit older actually. We have SFP 28 and QSFP, which is 4 times faster than that, and also QFS SFP 28 these days. And these are different types of modules that we have inside the switches. Some of them, of course, are obvious in here. Now, the speed is great. Now, when you use fiber, you go beyond, gigabits. And 40 gigabits is something which is used inside data center a lot. 100 gigabits is becoming very common these days. 400 gigabits are for fast core of the data center. And also these days, as of the time that I'm speaking right now, for 800 gigabits per second is coming. Now, 400 and 800 gigabits per second ports are very expensive. But in case you want to have AI data centers, for example, in that case, you have to go with this kind of a speed because AI needs a lot of speed. And AI, of course, is dominating these days. So what are the pros and cons of high-speed fiber? So let's just go for this. And here you can see that fiber is going to give you very high bandwidth, like I said, tens of gigabits per second, or even hundreds. It is future-proof. In the future, you're going to see only this kind of a connection. And for long distances, and also electromagnetic attenuation is kind of eliminated in here. But what are the disadvantages of using fiber? Actually, because this is very expensive, so you cannot really go a lot with fiber. It is very fragile, so you cannot really bend it a lot. So you should be very careful in a very tight spaces. Fiber is not going to be a good option, and also you need to have special tools and skills to terminate or repair this kind of things in here. Okay, let's talk about wireless. This is going to be the last type of connection, but wireless, of course, consists of different types. we talk about radio waves, but you should know that we have Bluetooth, we have, let's say, using light in the air actually, like for example laser beams or stuff like that, but they're not used so much, or let's say microwave for example, or different types of waves. But here most likely you're talking about radio waves actually, and for that you have different types of connection. Wi-Fi or wireless networking has different registered signals, and these are actually something worldwide. So you can go with other frequencies, but they are not registered for Wi-Fi. But for the sake of security, I have seen some places that they have done that. But I believe that you need to have a lot of clearances from government, and you need to have a lot of permits to use those kind of frequencies. But these are the frequencies that are available for public usage. So 2.4, which has a long range actually, but it is very crowded actually, and a lot of interference can happen in this kind of a network. 5 gigahertz is faster, cleaner, but the range is shorter actually. And now we have Wi-Fi 6 and 6E and even 7. And these are the latest generations. You can have tons of devices and use 6 gigahertz spectrum for this. And also we have a cellular network, which is your mobile network actually. We have 4G and 5G, and recently you know that there are rumors about 6G coming out, and because 5G was not so widely accepted, but 6G is just replacing 5G with a lot of advantages actually. So these are carrier-based wide area wireless, and great for mobile users, remote sites, backup links, and stuff like that. Where do you use wireless? When you want to have mobility, you want to move from one place to another place. So you cannot really connect using a cable. So that is going to be the where you use wireless. For guest networking, in case, for example, some people want to join your network, in case you don't have enough connectors. But wireless, of course, doesn't have this limitation of the number of connectors in here. You want to have flexibility, no cable runs. You don't really want to, run cable through the building. Or you want to have some temporary setups, for example, some events, some conferences in open space. You don't really need to create a network for that. So wireless is going to be the best part for that. But actually, there are again advantages and disadvantages for wireless network. For example, for the advantages, you don't really need to run cables. It is very flexible. It is very easy to add new devices to the network. Mobility is unmatched. You cannot really compare it to cable networks. But on the other hand, we have some problems. For example, interference. Like I said, we have walls in front of us. We'll have microwave devices. We have neighbor Wi-Fi's that are creating a lot of noise inside your network. Security risk, of course, is going to be a lot, because now the signal is available to everyone. It is not like cables that you can just reach that cable in a very limited place. But what you need to do is to encrypt the connection, encrypt the data transfer. Also, you have a slower and less consistent speed than what you have on wired. So wireless, like I said, is like flying, fast, convenient, but sometimes it has turbulence, so you cannot really do a lot with that. Okay, so let's recap. So what we have here is copper is for desktop access points, and if you want to have power over Ethernet, it should be less than 80 meters. IP cameras, phones, these are great for copper. Fiber is used for building-to-building connections, switch uplinks, data centers, long distances, ultra-high-speed links. Wireless is used for laptops, phones, guest networks, anywhere cabling is not practical, so you can just go with wireless. Most real networks are hybrid. So in a lot of networks, you see a combination of copper fiber and wireless. Copper is used for access layer, fiber is used in the backbone, wireless is used for mobility. So copper is affordable everywhere, great for LANs, power over Ethernet. Fiber is blazing fast, long distance, perfect for backbones. Wireless is flexible and mobile, and also great for end users. Remember to keep PoE runs under 80 meters. Use fiber beyond 100 meters and speed if you want to have a lot of speed. Then single mode is going to be used for long run. Multi-mode is going to be used for short run. And go wireless when you need flexibility and mobility. So in this video, we learned a lot. Please hit and like the video, and also subscribe to the channel. It really motivates me to keep creating more for you. And stay tuned. In the next video, we will go even deeper. How signals actually move through copper, fiber, and wireless, and why that affects speed and reliability. Thanks for watching, and I'll be seeing you in the next video.